Hello, welcome to the starting video in the series for design and analysis of reconfigurable systems. Today we are going to design a 1-bit and a 4-bit full adder in Intel Quartus and simulate it using Questa simulator. Now we can open here the Quartus Prime here. To create a new project in Quartus Prime, we can create a project from here, else we can also create a project from here. Now, as we have already created a project previously, we'll just open it. Now, to create new files in your project, we can generate new files from here. Here we can create any of the new files which we like, that is uh, Verilog files or block diagram files or VHDL files. Right now, we have already generated a Verilog full adder for 1 bit. So this is the Verilog file. Now this is set as top, so set as top level entity. So we'll just compile it. Now compilation takes a few minutes. Now as here you can see the compilation is done. Now we'll watch the critical parts for the design. So we'll go for the timing analyzer. We'll generate the timing netlist. And then after here we can see the netlist has been generated, and then now here we'll go to the report paths. Here we'll go for all report path. Here we can see that the protest path is from scene to out with the delay of 6.640. Okay, and now we'll simulate it. For that we'll go for from tools to RTL simulation. Here we can see that the simulator has opened up. Now we have already generated the test bench. So we'll go for here for compile. For error TB, compile, we got 0 errors. And then we'll simulate it. So we'll go RTL work, full error TB, right. So here we got all our variables in the objects. We'll drag all to the waveform window and we'll simulate it by using the command run all. So here we can see that for a 1-bit full adder, we generate the waveforms for scene, input 1, input 2, and we got the outputs as cout and out. So from here we can verify the working of a 1-bit full adder. Now we have seen the design for a 1-bit full adder and Verilog code. So now we'll check it for block design using a block diagram. So here we can see the block diagram design for a 1-bit full adder. We'll set it as a top level entity and we'll again compile it. Now here you can see that this block diagram file has been compiled. So now we'll check for the timing for the block diagram. The same process, generate the netlist and report path. So we'll get same. Then the shorted path is from input 1 to output. We can see this from here as well, which is input 1 to output, right? And so now we'll go for the test bench generation. For the block diagram, we'll go for process, start, and we'll go for start template writer for test bench. So we can see it has generated a test bench file at Questa. You can search it here as well. So this is the test bench template generated by the Quartus Prime. Now in this scenario, we have already generated a test bench. This is to show how it can be generated. So we'll use that. So we'll go for RTL simulation. For simulation, we'll do a similar step. We'll compile it first. And then simulate it. So here we got all the variables in the object window. Drag it to the view and then run all. So we got a similar output. So here we can prove that the 1-bit full adder is working properly. Now we'll move on to a 4-bit full adder. So this is the 4-bit full adder behavioral code. We'll set it as a top level entity and simulate it. So now we can see that the compilation is completed. So we'll go for the timing analyzer to check the paths and create timing netlist. Here we can see that the board is model assignments. Similar to the 1-bit adder, we'll go for report path and all. So here we can see that the delay is 8.070 and the path is from input 10 to the output 2. Here we can also see the pinouts and the total path from node N10 to node out 2. Now we'll go for the simulation of 4-bit full adder behavioral. We'll go for tool and run RTL simulation. Now for simulation, we'll first compile it. So this is 4-bit full adder test bench. We got 0 errors, and then we'll go for simulation. We got all object. Now add all the variables to the wave window and we'll run it. So here we can see, let me zoom it. So here we can see that for each the adder is working correctly. So this is how we have seen the working of a 1-bit and a 4-bit full adder using Quartus Prime and Questa simulator.